Ada kelas tak?
Tadi kelas ada kerja offline je madam. Jadi tak ada Google Meet apa.
Oh. Okay, saya start lah. Good morning everyone. Okay. So, I continue the previous question for question 39. So we left another 2 question for chapter introduction to organic. So saya cepat-cepat tu supaya you boleh concentrate lah nak buat kamu punya assignment kan. Alright. Okay, look at question 39. Draw the following structure into skeletal structure, and then on the skeletal structure you need to circle and name the functional group. Okay. Dah transform ke skeletal structure. Yes ni. How many carbon do you have? Okay, look at here. We have cyclic compound, right? Cyclic, 4 carbon. And then we have CH3 here. Okay, next is connected to C double bond O. Here is the C double bond O. And then the CH3 here. Okay, so this structure is correct. So what is the functional group? It's carbonyl group. And then Rahimi ada tak? Okay, and then we have multifidin ni. Draw and label the cis-trans isomer. So dia kata cis-trans isomer in the cyclic at the cyclic structure. So here we have carbon restricted rotation, and then we have two different groups. Okay, let's say both of the hydrogen on the top. Okay, so it will be cis isomer. Okay, the other one kita nak soalan kata pun nak cis trans. Okay, the other one you can draw like this. CL. Okay, yang ni H dekat bawah, at of the opposite side. Macam tak ni sangat kan. Kita boleh adjust lah dia. Okay, next so ni trans lah. Trans isomer. Okay. The other one you boleh buat, this one also will be the carbon restricted rotation. So the carbon restricted rotation can identify the two different groups. The fourth bond is hydrogen, while the second carbon restricted rotation is Br and hydrogen. So kita boleh buat satu lagi lah. Like this. One, two, and then we buat macam H. Another one is Br. Next is this ring. This group. The whole of this group. Okay. C, and then we have H double bond. The other one is CHEL. What's the double bond? Double one, 1, 2, 3. Ada double bond. 1, 2, 3. Ada double bond kat sini. So ini structure cis. So dia boleh buat strands dia. Okay. Boleh tak? So kat sini dia nak cis strand at the cyclic structure. So ini cis strands ni dekat luar kan, dekat substituent. Okay, Rahimi boleh? Boleh betulkan? Mana Rahimi? So orang lain pun take note lah. Okay, habis soalan ni. Lagi mana lagi yang homework? Apa lagi soalan yang tak check? Daniel Hakim. Question 41. Daniel Hakim dia? Okay. So, tak ada Daniel Hakim. Kita pergi ke Alkane. Mana. Okay. So, untuk Alkane, setiap chapter nanti in future, setiap chapter please buat mind map sendiri. So, your roughly mind map must have your physical properties and chemical properties. But basically for every chapter, what you are going to learn is how to name the structure and then draw the structure. What are the physical properties and the chemical properties? Okay, for alkane, you need to know how to name straight chain of alkane and cyclic alkane and then draw the structure. Okay, so this one is easier, but then must be very I would emphasize this one because you will draw the structure because it will use in your chemical reaction. Right. Next is the physical properties. So in alkane, you have boiling point. Okay, so whenever you want to discuss boiling point, please make sure what is the type of intermolecular forces. Okay, besides you can identify the molar mass. Okay, so if you are comparing the same alkane in terms of the same intermolecular forces, okay, you're comparing their molar mass, right? So since the molar mass is higher, that means the strength of intermolecular forces also is getting stronger. So the boiling point is getting higher. And then we have another physical properties which is solubility in water. So alkane is non-polar compound. It is non-polar. So it is insoluble in water. So insoluble in water means unable to form hydrogen bond with water. Unable to form hydrogen bond with water. Okay, next is solubility in organic solvent. So organic solvent, their intermolecular forces is van der Waals forces, and then alkane is non-polar, pun van der Waals forces. Van der Waals. Van der Waals. Okay, organic solvent is non-polar, alkane also non-polar. So how the non-polar connected? So there are intermolecular, there are van der Waals forces between non-polar molecule of alkane with the non-polar organic solvent. Okay. Next for chemical properties, kita ada dua jenis reaction, okay, combustion of alkane and then halogenation of alkane. For combustion of alkane is in excess oxygen and limited oxygen. So the product will be different. Nanti kita tengok soalan tutorial. And then the halogenation, you ada free radical substitution. Okay. The only reaction that free radical substitution is only in alkene. Okay, so who are assigned to do question number 1? Ini Kairin lah. Kairin. Kairin ni orang suruh lukis, dia tak nak lukis. Okay. Number 1. So in naming alkane, you need to choose the longest carbon chain. The longest carbon chain is 1, 2, 3, 4. Okay, it's not necessary the straight chain. In straight chain, we will get 3, 1, 2, 3. But we choose the longest carbon chain. No matter it's straight chain or bengkok ke, you ambil dia paling panjang 4. So if the longest is butane, and then we have the prefix, which is the substituent, which is methyl. Kalau satu carbon, methyl kan. Methyl located at carbon number 2. So it is 2-methyl butane. Okay, remember that between word and word, we are it must be close together, and then numbers and word must be separated by the hyphen. So letak. Dia hilang masa ni. Okay, next. Choose the longest carbon chain. Let us try carbon number 1, 2, 3, 4, 5. Okay, is there any longest carbon? 1, 2, 3, 4, 5. What else? 1, 2, 3, 4, 5. So kita pilih yang paling panjang adalah 5 carbon. Okay, 5 carbon. But 5 carbon with the that produce more substituent. Okay, we have another option. 1, 2, 3, 4, 5. Okay, so kalau kita ambil carbon chain yang saya highlight ni, yang saya numbering ni, you akan dapat berapa? 1 substituent, 2 substituent. Okay, so if we have 2 chain with same length, we choose the chain that produce more substituent. Okay, so our substituent is ethyl, and then the other one is methyl at carbon number 4. So who comes first? Okay, what is the parent name? If 5 carbon, it should be pentane. And then the substituent will be ethyl and methyl at carbon number 1, 2, 3. Okay, ada tak cara numbering yang lain? 1, 2, 3. Sama je kan? So it's optional. Kita nak buat 2 ethyl, 3 methyl, ataupun kita ada option lagi 2 methyl, 3 ethyl. Okay, daripada mana pun sama. Okay, 2 plus 3 is 5. Dia punya prefix dia 2 plus 3 pun sama juga. Tapi in terms of the arrangement of the prefix, we have substituent ethyl and methyl. So ethyl is E, alphabetical order. So ethyl is come first. So it should be 2 ethyl. And then 3 methyl pentane. Tengok jawapan Kari Nazmi. 3 ethyl, 2 methyl. Okay. So kalau tadi macam saya kata tadi, kalau sama option dia, pilihlah yang lebih proper untuk 2 ethyl, 3 methyl. Okay, yang saya yang salah. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2. Only 4. Okay. Jawapan kalian betul. Saya yang salah. 1, 2, 3, 4, 5. So this one ethyl, 2 methyl. Maafkan saya. 3 methyl, 2 methyl. Okay, so same goes to this one. 1, 2, 3, 4, 5, 6. So it will be hexane. Okay, the parent chain will be hexane. And then we have substituent. So your substituent will be methyl. So we have 3 methyl. That's the location of methyl. Carbon number 2, 3, and 3. Okay. Is there any other way to number it? It's we numbered from the upside part. 1, 2, 3, 4. So better we number from the below because the total number of substituent give the lowest possible numbers. So 2 methyl, we have methyl. All the substituent are methyl. So the prefix will be methyl. But how many methyl? It's 3 methyl. 1, 2, 3. So it will be trimethyl. Where is the location of 3 methyl? 2, 3, 3. So 2, 3, 3. So the number is representing the location of substituent. And then tri is to show that we have the same substituent, which is methyl. Okay, and this is the parent. Okay, so chirinazine 233 trimethyl hexane. Okay, yang ni dah betul lah. Ya. Yeah. Okay, number dengan number, comma, 2, 3, 3, and then hyphen, nombor dan perkataan. For D, longest carbon chain. Okay, so tengok dekat sini dia adalah C2H5. So kita cancelkan C2H5 ni, you buat CH3, CH2, CH3. So dia trik kat situ. Nak bagi nampak macam pendek kan. So C2H5 you tukar CH2 and this one is CH3. So kita nampak dah siapa yang paling panjang carbon chain dia. 1, 2, 3, 4, 5, 6, 7, 8. Ada tak cara lain? Kalau pergi atas 1, 2, 3, 4, 5, 6, 7. Okay, never mind. So this one. Okay, nak numbering dari kiri ke kanan. 1, 2, 3. Jumpa substituent. 4, 5, 6, 7, 8. So substituent kita kat mana? Carbon number 3, 5, and 6. From left, 3, 5, and 6. Okay, if we have the other choice, carbon number 1, 2, 3, 4. Number 3 ada substituent. Number 4 ada substituent. 5, 6. Number 6 ada substituent. So yang mana kita pilih substituent? Padahal carbon chain dia panjang yang sama kan. 1, 2, 3. Sekali lagi 3 methyl. 3, 4, 5, 6. So yang ni total is 11, 14. Ini 10, 13. 1, 2, 3, 4. 3, 4, 5, 6. So pilih yang mana? Numbering from the right. Okay. So kita numbering from the right and then choose the longest carbon chain. The parent will be 1. If 8, it should be octane. Okay. Substituent kita adalah methyl. Here is methyl. What else? This one is propyl. Tapi propyl ni attached to this carbon number 2. So dia akan jadi bentuk macam ni lah. Okay. This is the parent and then this is the carbon that attached to the propyl. Okay. And then sebelah kiri dia sama dengan sebelah kanan. So this propyl, this substituent propyl ni nama dia apa? Isopropyl. Okay, isopropyl. So siapa yang datang dulu? Iso ke I ataupun iso ataupun M? Should be I first. So if I first, I is located at carbon number 1, 2, 3, 4. 4 methyl. Sorry, 4 isopropyl. Okay, next adalah ada methyl dekat carbon number 3 and 6. 3, 6. Okay, dimethyl octane. The 6 dimethyl octane. Next, E. Okay, now the longest carbon chain you can see here is the cyclohexene. So we choose the cyclohexene. Tapi nak numbering daripada mana? Okay, you boleh pilih 1, 2, 3, 4, 5 ataupun 1, 2, 3, 4, 5. Okay, kalau clockwise, try satu-satu lah. Kalau ni kan, ke bawah ni, 1, 2, 3, 4, 5. So, 1, 2, 3 substituent dia. And then, substituent at number 5. Ataupun, kalau ni nak numbering daripada atas ni, 1, 2, 3, 4, 5. So, kalau merah ni, 1, 3, 4, 5. Siapa yang banyak? The 6 dia. 8, 9, 10, 11. 9, 10, 13. So yang colour purple kita numbering ni. Okay, parent dia cyclohexane. 6 carbon. Cyclo is to show that cyclic compound. And then how many carbon in the ring? It's 6. So we cyclohexane. Okay, the substituent are methyl. And then this one is ethyl. Okay, who comes first? Ethyl. Alphabet kan? And then ethyl. Right. Where's the location of the ethyl? At carbon number 5. And then how many ethyl is trimethyl? Trimethyl. Where is the location? Carbon number 1, 2, 3. 1, 2, 3. So 5 ethyl, 1, 2, 3 trimethyl cyclohexane. Okay, and then cyclopentane. Okay, terus saya kata dia sebagai parent sebab dia carbon chain yang paling panjang. So dia adalah cyclopentane. Okay, lagi ada substituent. Okay, nampak dekat carbon ni, I put carbon number 1, number 2, number 3. Sebab apa? Supaya substituent kita jadi 1 plus 1 plus 3. Instead of 1 plus 3 plus 3 kan. 1, 2, 3. Okay. So who comes first? We have bromo, we have methyl, and then we have ethyl. So bromo, and then followed by ethyl, and then followed by methyl. Okay. Location of the bromo at carbon number 1, and then ethyl at carbon number 3, hyphen, and then methyl at carbon number 1. Okay. Tengok, Kari Nazmi, 5 ethyl, 1, 2, 3 trimethyl cyclohexene as a parent. 1 bromo, 1 methyl, 3 ethyl. Okay, very good. Thank you, Karin. Okay, we move to question number 2. Number 2 siapa? Nazmi. Number 2, draw the structural formula for each of the following. So we need to draw 1,1-dichloro. So ni lebih penting lah daripada you naming tadi kan. Sebab kalau drawing you kena betul sebab akan buat reaction. Kalau naming, at least satu salah, satu je lah markah hilang. Kalau naming, kalau drawing ni salah, the whole equation akan salah. Okay. We start by the parent. Okay, look at parent is cyclohexane. Okay, 6 carbon ring. And then we have methyl at carbon number 3, 1,1-dichloro. So this is carbon number 1, ada chlorine 2, and then 3 methyl. Methyl at carbon number 3. Okay, heptane. Heptane is 7 carbon. 1, 2, 3, 4, 5, 6, 7. Lagi apa lagi? 2 dimethyl. Carbon number 2. Ada methyl. Ada methyl. Actually kalau you buat skeletal ni tak payahlah buat CH3 dah. Tak tulis macam ni pun tak apa. Macam ni kan, kalau kita tak nampak CH3 ni kan. We understood that here is the carbon also. Okay. Okay, sebab dia tak restrict you untuk buat structure apa, tak kisah, tak ada masalah. Okay, next is 3 cyclohexyl. At carbon number 3, there is cyclohexyl. Cyclohexane when become substituent. So here, cyclohexane is substituent because our longest carbon chain is 7. So pilihlah yang paling panjang untuk jadi parent instead of 6 carbon. Okay, so tak semestinya untuk ring dia akan jadi parent saja. Okay, see, draw 1 bromo, 5 chloro, 3 ethyl, 3 methylpentane. Pentane is 5 carbon, 1, 2, 3, 4, 5. And then at carbon number 1 and 5. 1 is bromo, 5 chloro. Number 3 ada ethyl. Correct. Number 3 ada methyl. Correct. Okay, tak ada masalah. D. Nonane is 9. So dia buat 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 2, 4 dimethyl. At carbon number 2 and number 4 ada methyl, ada methyl. Next is butyl at carbon number 5. Okay. Here is butyl, carbon number 5 kan. Okay, macam mana kita nak buat sec butyl? Sec is referring to the secondary carbon. Macam mana nak lukis secondary carbon? Okay, this is yours parent chain and then connect to this carbon, right? So this carbon to be secondary, tidak termasuk carbon yang dia melekat pada chain tu. So dia ada berapa carbon untuk dia jadi secondary? 2 carbon. Okay, maksudnya kat sini ada hydrogen. I repeat. This is the carbon of the substituent that attached to the parent. So this carbon must be secondary carbon. And then to be secondary carbon, it must attach to 2 carbon. 1, 2. Not including this one. Okay. So sekarang kita dah buat 3 carbon. Another one, the 4th carbon is located, either you nak letak sebelah kanan sekali atau kiri sekali, tak ada masalah. So this is the side butyl because it connected to two carbon. Okay. So the structure is correct. Okay, thank you, Nazmi. Number 3. Arrange the following alkane in order of increasing order boiling point. So this question check jawapan masing-masing lah. Sharon. Okay. So dia bagi option dekat sini. Number 3, nonane, pentane, decane and heptane. So we are arrange them. Sharon lah. Sharon dia susun ikut molar mass, increasing molar mass. Pentane is 5 carbon. Heptane is 7 carbon. Nonane 9 carbon. Decane is 10 carbon. Okay, by looking to the number of carbon, so we can see that their molar mass is getting increased. Okay. So since the molar mass is getting increased, the van der Waals forces also getting stronger as the molar mass increase. So look at here how bila you nampak je boiling point, must mention the type of intermolecular forces tu. Yang ni yang kena consider. Okay, nak tengok Sharon jawab macam mana. First of all lagi. You can essay tau. You straight to the point je Sharon.
Okay, madam.
Apa tah? Pentane has 5 carbon. Heptane 7 carbon. Okay, this one can be simplified by the molar mass is getting increased from pentane to decane. Okay, simplify this one. Okay, so decane has the biggest molecular size, bigger surface area and stronger van der Waals forces. Okay, and then more energy required to separate the molecule. Then separate to overcome intermolecular forces ataupun van der Waals forces. Therefore, boiling point dia tinggi. Okay, then dia bincang yang rendah tu. Okay lah. Sebab ni trend dia increasing molar mass. So you need to mention okay, tengok Sharon.
Yes, madam.
Molar mass, bigger molecular weight or size, surface area getting higher, and then van der Waals getting stronger. Therefore, more energy is required. Amboi, macam kau dapat skema je, Sharon. Kau tengok buku.
Madam, I used the notes. I did not use any schema.
Point increase the molecular weight.
Dalam nota tu dia tulis macam tu. Saya tak guna itu skema semua.
Okay. Tak masalah lah. Okay, next is one. 2,2-dimethyl propane. Okay, methyl ni ada 2. Dimethyl 2 carbon and then propane 3 carbon. So total 5 carbon. 2 methyl butane 4 carbon, methyl 1 carbon. So 5 carbon and pentane is 5 carbon. So we can see here their molar mass will be the same. Okay, because their total number of carbon is the same. Tapi apa yang membezakan dia? Kenapa dia susun macam ni? Increasing boiling point. Why is it pentane will be higher boiling point compared to 2-methyl butane? Why is it 2,2-dimethyl propane is the lowest boiling point? So, here is, okay, mula-mula dia kata all this structure has same molar mass. Sebab apa? Macam mana kita boleh kesan dia molar mass? we can draw the structure. So we can count the number of carbon. So if they have same number of carbon, they have same molar mass. Okay. For the branching alkane, tengok kat sini, ni ada 2 branch. Ini ada 1 branch. Yang ni linear terus tu 3, 4, 5. Okay. Tengok jawapan Sharon. But the boiling point of the branch isomer is lower than the boiling point of unbranched. Sebab apa? Two-dimethyl propane has more branching. Okay, so what happened to the branching? Masih tak menjawab? Jawab. Mana jawapan? More branching than pentane. Yes. Sharon. As branching increase, molecules become spherical in shape. Ni. Okay. So, bila dia banyak branching, smaller surface area make the contact with the neighboring molecule. Okay. And therefore weaker van der Waals forces. Okay. So dekat sini kita boleh buat conclusion daripada jawapan Sharon ni. For the linear alkane, higher surface area. Okay, apa kena mengena dengan surface area ni? So ni 1, 2, 3, 4, 5. Okay, ni satu molekul pentane. Ini molekul kedua pentane. Okay, nampak dia linear. So the surface area, contact area dia besar. So dia punya intermolecular forces dia tu, dia boleh memegang molekul tu antara satu sama dengan lebih kuat. Okay. Nak cakap tadi, higher surface area, stronger intermolecular forces. Stronger intermolecular forces, kita nak buat apa? Nak boil kan? Nak overcome intermolecular forces ni. So, require more energy. If you need require more energy, so boiling point akan tinggi. So, compared to the branching alkane with the same molar mass, kita akan dapat 2, 3, ini satu molekul, 5 carbon, ini pun satu molekul. So, for the branching, if more branching akan menyebabkan apa? Surface area, lower surface area between the molecule. So, kalau molekul ni dengan satu lagi molekul, surface area dia kecil, boleh ke dia pegang dengan kuat? Tak kuat kan? So, intermolecular forces dia weak. Yes, intermolecular forces weak. Apa yang terjadi? Require less energy to overcome the intermolecular force. Therefore, boiling point dia akan rendah. Okay. Satu lagi, kalau kita compare, total number of 5 carbon juga kan, kita ada cyclopentane. Okay, let's say we have cyclopentane. 5 carbon juga. Tak baca cyclopentane kan tak cantik lah. Tak lah. Okay. So you imagine that cyclopentane ni dia macam satu kertas lah, sekeping kertas. Ni dengan ni. So one cyclopentane with another cyclopentane, dia akan duduk dan stack yang macam ni. Ni sekeping cyclopentane, ini sekeping cyclopentane. Ni cyclopentane yang seterusnya. So dia punya surface area lagi tinggi daripada linear. So intermolecular force dia lagi kuat. Energi yang diperlukan lagi banyak. So boiling point dia lebih tinggi. So if we need to arrange them, branching alkane for the same molecular mass, branching ni lebih rendah. And then followed by linear chain. And then cyclic lebih tinggi. Okay, increasing boiling point. Boleh? Let's say lah, contoh lah nanti kat mana-mana jumpa kan. Okay, kalau dia bagi yang ni 5 karbon, ini pun 5 karbon, ini pun 5 karbon. Molar mass dia sama. So antara cyclic dengan linear, cyclic dia lebih tinggi. Okay, manakah jawapan Sharon tadi? Mana? Oh, tadi lah kan? Sorry, I'm sorry. Terkejut je.
Madam. Madam.
Dah habis ke belum? Oh, last one. 3C kan? Sekejap. I'm lost. Here we have 1, 2, 3. Okay, expand the structure. CH and then CH3 and then this one CH3. Okay, then this carbon CH3. Okay, the other one is CH3 and then we have 2 CH2. Next is CH3. Another one is this one. CH3 and then kita ada CH2 ada 3. 1, 2, 3. Okay. Okay, now why Sharon arrange like this? 1, 2, 3, 4. 4 carbon. This one is 1, 2, 3, 4. 4 carbon. Okay, so kita ada 4 carbon branching, 4 carbon linear. So ini 5 carbon branching and this one is 5 carbon linear. So very easy to arrange, right? Okay. So here kita kena bagi tahu macam mana kita susun. Kena baca Sharon punya jawapan. Has higher boiling point. Okay, yang ni 5 carbon, 4 carbon. Has higher boiling point than CH3 tu 2, 3, 4 carbon tapi branching. This is because has branching plus branching compared to this one. Okay, where is the keyword? As branching increases, molecule become more spherical in shape. This result in smaller surface area. Okay, this is weaker van der Waals forces. Okay, so Sharon explain, dia compare this one. 4 carbon branching dengan 4 carbon linear. So yang paling rendah boiling point adalah 4 carbon yang branching. Okay, and then mana yang paling tinggi? Lower boiling point. Sharon! has 4 carbon and has 5 carbon. So the more the carbon, macam mana kita nak senangkan? Okay, once kita nak mudahkan pemeriksa, check lah kan. Dia boleh label lah. Can label this one is A, B, C, D. Lepas tu explain satu-satu. Between A, B, C, D. A dengan B ni, A and B has same molar mass. Tapi kenapa B lebih tinggi? B higher boiling point than A because. Okay, bagi tahu sebab apa. Sebab dia linear, surface area dia lebih tinggi. Okay. Lepas tu you compare C higher than B. Bukan cara je, orang lain pun take note lah. Okay. C higher than B. Sebab apa? Sebab C has higher molar mass. Sebab ini 5 carbon, ini 4 carbon. Okay, next. Compare D dengan C. D has higher boiling point sebab apa? Explain. Okay. So yang ni linear 4 carbon. Ni branching 4 carbon. Okay. 5 carbon linear. 5 carbon branching. Okay. You know the factor. So explain accordingly. Kan tak bagus Sharon explain tapi kena menyeluruh lah. Dia hanya cakap generally this one je. Kalau you general explain untuk 3A is okay. Sebab dia punya trend dia adalah molar mass. Tapi untuk C ni dia ada banyak faktor bila kita compare. Okay. Number 4. Explain why is butane. So ini jawapan Zulfahmi. Kenapa dia butane is soluble in benzene ring but insoluble in water. Tadi saya dah mention dah. Butane is insoluble in water because it's non-polar molecule. Okay. Cannot interact with water. So, unable to form hydrogen bond with water. Okay, kenapa dia kata insoluble kan? Okay lah. Unable to form hydrogen bond with water. Next is number 5. Write the balance equation for the combustion excess oxygen dengan limited oxygen. Siapakah orang yang si Ainur kan? Mana Ainur? Ya, madam. Okay, untuk excess oxygen of propane, dia akan hasilkan CO2. Tapi untuk limited oxygen, dia akan hasilkan monoxide. Kalau dia further lagi oxidation pembakaran ni, combustion ni, sampai dia akan dapat carbon dan juga water. Okay, kira kalau cukup oksigen, dia akan dapat CO2 lah. Kalau tak cukup dapat CO, tak cukup lagi very limited. Kalau another very limited oxygen, dapat carbon saja. Okay. So, apa nak cakap dekat sini? Excess. Tak ada apa-apa. Ni okey je. Oxidation. So, thank you, Anu. Number 6. Explain why alkane are generally unreactive. Kenapa unreactive? Saturated meaning that all single bond, and then non-polar bond, yes, correct. It contain only bond of carbon, CH and or comparatively tight and difficult to break. Okay, keyword dia adalah saturated and then non-polar. Okay, number 7. We have another 10 minutes. Okay, tengok Azra jawab apa. Untuk ni, propane react with bromine. Okay, in the presence of UV, ada dua produk. State the type of reaction. So, kita dah belajar type of reaction where alkane all are single bond. So, bromine is substitute the hydrogen. So, dia adalah substitution. Tapi masuk sebagai apa? UV break bromine. So, it is when UV break bromine, so it form free radical. So, free radical substitution. Next, what is the function of sunlight? So, it's provide energy for the homolytic cleavage. Okay, UV ni yang akan break bromine. Kalau tak ada UV, reaction tu tak jadi. Draw the structure of monosubstitute product A and B. Okay, if we expand the structure of the propane, okay, the bromine has three options to substitute hydrogen. Ada hydrogen number 1 atau dia boleh pilih hydrogen number 2. Kalau kat sini pun consider as hydrogen dekat carbon number 1 jugalah. So sebab ni primary carbon. So ni primary, ni secondary, ni primary carbon. So yang mana yang lebih stabil? Kita dah belajar stability of free radical dulu. Kalau kita substitute secondary free radical is more stable than primary free radical. Okay, tengok balik nota stability of free radical. Since we have two option of free radical, okay, kalau dia nak attack carbon ni, bromine masuk dekat sini. Kalau dia carbon number 1, bromine masuk kat carbon number 1 lah. Okay, tapi kalau dia masuk dekat carbon number 1, maksudnya dia akan pergi making a bond with the primary carbon. So primary free radical is less stable than secondary free radical carbon. So kita dah belajar sebelum ni, secondary is more stable. More stable means more favorable to undergo the reaction. So maksudnya bromine akan lebih suka pergi substitute dekat carbon number 2. So you ada produk yang ni, and then the other one is Br at carbon number 1 as a minor product. So yang kenapa dia major? Sebab apa? Dia datang daripada secondary free radical, which is more stable than primary free radical. Okay, more stable maksudnya more favorable to undergo reaction. Okay. Within 5 minutes, we will look into the mechanism. Okay, look at here. We have UV. UV break bromine. So they break homolytically. Means daripada bond, satu elektron pergi ke bromine, the other electron will go to the other bromine and left the bromine to be free radical. Next is the propagation step. Okay, tengok ni initiate maksudnya nak start tindak balas tu. Start reaction. Okay, once bromine free radical dah dihasilkan, tahu tak free radical tu, you ingat free radical ni jahat. Sebab tu kita kena pakai sunblock. Sebab UV tu akan menghasilkan free radical yang akan penetrate kulit kita tu. Okay, so nanti akan ada pigmentation dekat kulit kita. So Br free radical ni, you ingat dia jahat ya. Okay, so since dia jahat, dia buat apa? Dia pergi attack yang neutral kat sini. Okay, kita tengok dekat bromine produk ni, dia nak hasilkan, nak masuk dekat carbon number 2 kan. So you can attack carbon number 2. So your arrow is towards this one. Salah. Kat sini yang senang. Dia pergi kat sini. So apa yang terjadi? Hidrogen ni kena keluar. Karbon dengan hidrogen ni kena keluar. So, satu elektron menyebabkan bila bromin pergi kacau, satu elektron menghala ke karbon, satu lagi elektron menghala ke hidrogen. Menyebabkan dia ada H dot and then Br dot. Okay, so bila dia bergabung, dia dapat HBr ni. Tapi yang kita nak tengok sekarang adalah karbon ni. Okay. Bila satu elektron diberi ke arah karbon, karbon ditinggalkan menjadi free radical. So, dapat penjahat yang baru. Nampak ni? So, dia buat tadi satu je kejahatan. Sekarang dah ada geng kejahatan yang kedua. Dia attack yang neutral ni. Dalam reaction kita, bukan ada satu bromin ni je tau. Bukan ada seketul bromin. Ada banyak molekul bromin. So, dia attack bromin yang lain. Bila dia attack bromin yang lain, bromin ni pun break homolytically juga. Okay. So, bila dia break, and then dia bergabung. Br bergabung dengan karbon ini. That's why ada Br di sini. And leave this Br to be Br radical. So, benda ni tidak akan habis. Asalkan radical attack yang neutral, dia akan generate new radical yang baru. So, apa yang you buat dekat propagation ni, ingat, radical, free radical, attack yang neutral. Sebab apa? Nak sebarkan kejahatan supaya dapatkan radikal yang lain. So benda tu takkan habis. Radikal ni akan attack pula yang Br2 yang lain. Br ni akan attack alkane yang lain. Sebab dalam ni propane ni ada banyak kan. Okay. Sampai bila benda ni nak habis? So you need to stop. That's why nama dia termination step. Stop the reaction. Terminate. Okay. So bila dia terminate, kita ada 3 jenis radical. 2 jenis. So 2 jenis radical tu ada 3 combination. Number 1 is bromine radical dengan bromine. Another one is alkane dengan alkane. And then alkane dengan bromine. Okay. 2 spesies tapi 3 jenis combination. So kalau ni dia bergabung, dia share elektron balik, forming a bond. Dapat Br2. This one, making a bond. Okay, carbon ni bagi satu bond dengan carbon ni, share. Make a new bond. This is the new bond form. Producing the new alkane, the longer alkane. Another one is when Br make a new bond with carbon, there will be carbon Br bond here. So nama dia halo alkane, where the halogen is attached to the alkane. Okay, last one. 2 minutes. Dia punya bromine tu kalau dia tindak balas, dia akan jadi reddish brown, colorless. Dia tak akan jadi decolorized ataupun kata dia colorless pun okey je. Okay. Kalau kita simpan dekat tempat gelap, tak ada UV, that's the reddish brown bromine color is unchanged. Maksudnya apa? Ada tindak balas tak? There will be no reaction, no halogenation. Sebab apa? Sebab nama dia initiation. Okay, to initiate the reaction, we need the UV. So kalau untuk tindak balas ni, dia tak letak UV, salah. Okay. Right. So I'll stop until question number 7. Okay. Next, soalan 8 adalah Farad Izzati kan. So we will further discuss next class. Thank you for joining this class. Balik buat mind map tu semula lah. Lengkapkan mind map dan tengok balik soalan 1 sampai 7 yang mana yang bermasalah. Alright, see you. Thank you. Bye.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Madam.